Welcome to HGS Assist. It's been long we did a video. I think this is about how many months now we've not done a video, but it's all right. Hello, I'm very good, sir. You gonna need to come. You gonna need to come. Yeah. Yes. 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 I forget. I forget seriously. I forget. Okay. Okay. Sorry for that. We have 2017 MacBook Pro 1708 820 00239A. Customer said no power. Hello. Hello. Good afternoon, sir. My brother, I'm very, very sorry. Dozier, right? Abi Donald. What's it called? What's the name? Donald Abi Dozier. Huh? No, sir. Yes, no, sir. No, sir. No, sir. Okay, no, sir. Um, Give me a call in the next 1 hour. In the next 1 hour, please. Okay. No. I can't silence your phone. Okay. We have the system which the customer said no power. With the physical inspection, nothing was seen. Everything on the system on the motherboard looks clean and looks very fine. So first of all, we are going to do what we normally do. First, test for PP bus if it's shorted. The reason why I normally do that on this motherboards are because, on other MacBook systems, you can only identify PP bus very easy, very fast when they have indicator lights on the charging side, but on Type C systems it's not like that. You see that you use your USB-C, which is this. Use USB-C, or you use your meter to test for continuity on the PP bus line. So where is the PP bus line? Look here closely. The fuse line. This is the PP bus line for this motherboard. This green chip here. This is a fuse line. So remember, a fuse is kind of a chip that helps to control power. Now when the positive line and the negative line are beeping continuously when connected to ground, automatically it simply means that your PP bus line is faulty. That alone cannot make your system to work. Let me clear here a little so we can start up on this one now. And let's check if our flex camera is on. Let's check if our flex camera is on. Okay, flex camera is on. So now how do I check for the PP bus? Remember, you set your meter gauge to continuity. Your meter set to continuity. Now I place my black probe on the ground. Every iron part on the motherboard is the ground of every motherboard. Same applicable to other systems. The ground ports, the iron ports are the ground. So I place my black probe on the ground. I place the positive probe on any of the PP bus fuse line. Here, I put on here, it's still beeping. I place on the first line, it's still beeping. So automatically, the PP bus line is grounded. So they are short on this system. So I think some of my videos I've given you guys some simple way to check for short, possible ways to check for short on this type of system, because normally what I normally do on this type is I inject voltage. So if I inject voltage, I feel with my palms, or I use my flare camera to identify where the short is coming from. So now what we are going to do now is inject voltage. So I have this little machine that I'm using here, that I use in injecting of voltage. So remember, PP bus is mainly on 12 volts power supply. 12 volts mainly on the PP bus, 12 volts, but mainly just 12 volts. So I'm going to inject 12 volts on this line and see the results. So let's go. I'm cleaning the terminal of my LED, soldering LED to have a better view, a better connection. So let me just make you guys to be seeing exactly what I'm doing from the camera also. Yeah. Okay. I believe you are seeing what I'm doing here. So I want to add LED to this the PP bus fuse line. What I actually want to do is just to inject voltage. So this is the positive probe of my DC machine, little DC machine that I normally use in my work. Okay, so as you can see, let me do it well. Let me do it well. Hello. I'm very good. You want to do what? You want to do what? Boardwalk. What's the issue with the system? Yeah, come inside. Okay, nothing coming. Okay, guys. Now we've set it up now. So let's inject the voltage now. So we'll allow it to cool off. Let me have this one here. So not have too much light on the plate for that. What's the issue, sir? Okay, so let me hope you guys are seeing what I'm doing. Okay, So now I inject by putting the negative probe on the ground. I've done that now. So let's look around with our flare camera to see where and where there is hot. Are you seeing anything? No. Sorry. Are you seeing anything? Yes. Are you seeing anything? Yes. Are you seeing anything? Yes. Let's remove. Now, you guys should look closely here. Look at the circuit around here now. So, let me place the probe again from this angle. Are you seeing what is going on there? With our flare camera, here particularly is giving us a heat of 40.5 degrees centigrade, which is not normal. This is not normal. So automatically we have our first error from here. So let's look at the back also and still inject to see if there is any possible error also. Okay, from here none, from here none. Look this way also, none. Also look this way. Okay, so closely you can see and you can tell that where this error is coming from mainly is from this angle here. So what do you say? Is a done deal. Now we are going to eject our DC power. We are going to eject it out. Okay, now see, this is where we have that error here. Now I want to tell you guys that some guys normally have an eye opener on these things. So now see closely, this is the cap in quotes that is bad. You know, I've looked at this thing right for how many hours? I couldn't see anything now, but look here now closely. You will see that this cap is dead. I see, and this is exactly what is keeping this system from coming up. So now we are going to pull it off. Apply oil so as to soften the lead. There are some cap that when they are faulty you can easily identify them, and there are caps that when they are faulty you can't identify them. So all these things are just it's good to have some devices that will help you to identify such errors, because there are errors that mere looking at it you can fish out the particular one that is bad. So, and don't forget, it's good to have scrap balls, but we call it donut balls. So it's very good to have it in a large quantity. Like me, I spend most of my money on scrap boards. So I'm going to take it from here. Yeah, this should be the cup. Alright. Yeah, there's a pour cup. So this should be the cup. Okay, so let's take it out from here. It's a pour cup, so you don't need to bother yourself. Just pick it out. Okay. Okay. So we'll fix it in now. We allow to cool off. Now don't forget to do what this particular step I'm doing now. Whenever you're working on a motherboard and you fix any chip or you replace any chip, do not rush to plug in the DC charger on the motherboard. That should don't be the first thing to do. What you need to do first is to check if there is still short present on the system. What my boy did today, which is very very wrong. I think they should be on this board. There's a bridge on this line. After fixing it, he didn't identify the bridge. He plugged in charger. So now the error on this board has been multiplied. Already what we are having on the first line was, according to him, was a short on the RAM side. A short on the RAM side simply means that the SMC is not going to be able to transmit or interpret the power line coming into the board. So now you solving the problem by removing the chip and now not looking closely or looking very well, a lead has merged between two different chips. Looking at it now, we are going to face a very big work on this motherboard, a very big one. So now back to our board. Remember, we encountered short on the PP bus line. So what can you say about this first beeping? Every capacitor stores current. Once a capacitor stores current, when you place your meter on continuity to it, there must be continual beeping till the current on the capacitor is discharged. That's when you will know the effectiveness of the capacitor. So now I place my meter on our PP bus line. There is no short. I place it on this line. There is no short. So automatically, me particularly, I believe that this board is now working. So now let's put it to test now. I've connected the charging line. Connected the charging line. Now my USB-C is plugged on. Now I connect my USB-C. Now remember, we are having short. When you have short, you have 5 points. Now on here we are having 19 volts. Now we have 19 volts, 0.7, 0.80. That means our board is back to life. So thanks for watching. We'll upload the next video when it's being coupled. So thanks for watching.
How are you, my friend? How do you do, my friend? I don't short video, not be long videos, you understand?
us information now. You don't do.